Hey everyone, welcome back to my channel. Today we're going to tackle a medium-level problem on LeetCode. Path existence queries in a graph I. This problem is all about finding whether two nodes are connected in a graph or not. So, let's dive right into it. The problem gives us a list of numbers and a threshold value. And then we have to answer some queries. Each query is a pair of nodes. And we need to tell whether these two nodes are connected or not. The connection is defined based on the absolute difference between the values of the nodes and the threshold value. If the absolute difference is less than or equal to the threshold, then the nodes are connected. Now, let's talk about the intuition behind this problem. Think of it like a social network where each person is a node. And they're connected if they have a similar interest, which is represented by the absolute difference between their values. We can use a union-find data structure to keep track of these connected components. Imagine you're at a party and you want to know whether two people are in the same group or not. You can just ask their friends. And if they're all connected, then they're in the same group. That's basically what the union-find data structure is doing here. So, here's how we can approach this problem. First, we create a union-find data structure with n nodes. Then, we iterate over the list of numbers and union the nodes that have an absolute difference less than or equal to the threshold. After that, we can answer the queries by checking if the two nodes are in the same connected component. It's like asking whether two people are in the same group or not. Now, let's take a look at the code. We start by defining a union-find class that has a parent vector. In the constructor, we initialize the parent vector with n nodes. And each node is its own parent. Then we have the find function, which finds the root of a node. If the node is not its own parent, we recursively call the find function on its parent. And we do this until we find the root. We also have the union nodes function, which unions two nodes by making one of them the parent of the other. In the solution class, we create a union-find object with n nodes. And then we iterate over the list of numbers and union the nodes that have an absolute difference less than or equal to the threshold. Finally, we answer the queries by checking if the two nodes are in the same connected component. Now, let's talk about the time and space complexity of this solution. The time complexity is O n log n plus q asterisk alpha n, where n is the number of nodes and q is the number of queries. The reason for O n log n is that in the worst case, we are iterating over the list of numbers and performing a union operation for each pair of nodes. The reason for O q asterisk alpha n is that for each query, we are performing a find operation in the union-find data structure. The alpha n factor comes from the amortized time complexity of the find operation in the union-find data structure. The space complexity is O n for storing the union-find data structure. That's it for today's problem. I hope you guys understood the solution and the intuition behind it. If you have any questions or you want to share your approach, please comment below. Don't forget to like the video, subscribe, and comment your approach below.